Moving on to Chapter 7, 7.1. All of Chapter 7 actually is about systems of equations. So we need to first define what a system of equations is. It is simply a set, meaning two, a set of equations in the same variables to be graphed together on the coordinate plane. Now there are three different ways that you can solve a system of equations or find the solution of a system, which we'll get into in this chapter. But the solution of a system is simply an ordered pair which is just a point, xy, that satisfies both equations. So it has to work for both equations for it to be a solution of the system. Today, we're going to focus on just the graphic method. So when you're doing the graphic method, specifically, it is the point or the ordered pair where the two lines intersect. That's pretty easy, okay? So we know how to graph lines. You're simply going to graph two lines and find where they intersect, okay? So first, there's two things we're going to do here today. Decide whether an ordered pair is a solution of the system. Now, based on this first point here, it says an ordered pair that satisfies both equations is a solution of the system. So we need to test this ordered pair with both equations and see if it works for both equations. And then we'll check this other ordered pair and see if it works for both of these equations. So remember, in a coordinate point, this is always your x, this is always your y. So we're going to start with this equation first. 4 times your x value, which is 5, minus 5 times your y value, which is 4, equals 0. And then we test this, or we simplify the left side and see if it's equal to 0. So 20 minus 20 equals 0, and 0 does equal 0. So that one does work. But again, an ordered pair has to satisfy both equations to be a solution of the system. So now we need to test this equation. 6 times the x value, which is 5, minus 5 times the y value, which is 4, equals 10. Now 6 times 5 is 30, minus 5 times 4, which is 20, equals 10. 10 equals 10. So this one works too. So does it satisfy both equations? Of course it does. So yes, it is a solution to the system. Now we need to check this one. 10, 8. So again, we'll do 4 times, doing the first equation, 4 times the x value, which is 10, minus 5 times the y value, which is 8, equals 0. So we get 40 minus 40 equals 0. That one works. Now let's check this one. 6 times the x value, which is 10, minus 5 times the y value, which is 8, equals 10. 6 times 10 is 60, minus 5 times 8, which is 40, and we get 20 equals 10. This one does not work. So because this coordinate point does not work for both equations, then this point is not a solution to the system. Now let's imagine, if we graph these two lines, how many possible places can they intersect? That's a good question. So we're thinking in our mind that they could probably only intersect in one place. So if this point works, then how could this point work? But there are other ways that two lines can intersect. So you think about that, okay, as we move on to the next set of problems here. Solving a linear system. Now, these two equations are already graphed on this grid, and we just want to find the solution. So remember, the solution is simply the point where the two lines intersect. So you're just naming a point. So half the work is already done for you in number one. We just want to find the point where these two lines intersect, which is going to be right here. And you just need to name that point correctly. Remember, you need to go on the x-axis first, which means we're going back 1, so that's -1, and you're going up 1 on the y-axis, so that's +1. So the solution to this system is -1, 1. What about number 2? What would the solution to number 2 be? Okay, they cross here, and you just name that point. 1, 2, 3, and up 1, 2, 3, 4. So 3, 4. Easy enough. Now these were already graphed for you. The lines were already graphed for you, and then you named the solution. Now in the third section here, we're going to do all of it ourselves. Graphing and checking to solve each system. So in number 1, we're asked to graph these two lines. For us, this is nice because they're both in slope-intercept form. So we just need to remember how to graph in slope-intercept form. So remember, 1 is your y-intercept. Remember, I always say we graph backwards. The y-intercept comes first. What is the slope of this line? Well, there's an imaginary 1 here, which means the slope is 1 over 1. So we go up 1 and over 1. Now, in this section, in this chapter, it's very important that your lines are exactly straight. And you could use a ruler for that, but sometimes when we use a ruler, we get it off just a little bit. So we want to make sure that we use our slope multiple times until we get to the end of the grid on both sides. For the first line, I'll show you what happens with the second line. But for the first line, in order to make sure it is perfectly straight, you need to do the slope all the way in both directions until you go off the edge. Now, when we get to this one, we have a y-intercept of 5, 1, 2, 3, 4, 5, and our slope is -1. So we're going to go down 1 and over 1 this time because the imaginary number there is 1. So we go down 1 and over 1, down 1 and over 1, and when you hit the line, you can stop doing your slope because at that point we have found the answer to the question, which is naming the point where these two lines intersect, which is this point right here. So you can't just do what I just did there and make it bigger. You have to actually name the point because that is the solution to the system. So what point is that? 1, 2 on the x-axis and 1, 2, 3 on the y-axis. So in order to graph a solution or find the solution using graphic method, you need to graph the two lines and name the point where they cross. Okay? In number 2, we have to do a little more work because it's not in slope-intercept form yet. So we need to get y alone by subtracting x from both sides. So we get y equals -x minus 2. Oops, sorry about that. And then we can graph that line. So we're going -2 is the y-intercept. Again, we have an imaginary 1 there, which makes this -1 over 1. Down 1 over. Keep going in both directions, but only for the first line. Okay? And then connect the dots. Okay? Now, in the second one, we have to do even more work to solve for y. So we've got to move this 2x over and get rid of this -3. So we're going to subtract the 2x first. We get -3y equals -2x minus 9. Divide everything by -3. And we get y equals a negative divided by a negative makes that positive 2/3 x. Negative divided by a negative makes that positive 3. So we go up 3 on the y-axis, 1, 2, 3. And the slope is 2/3. Now, if I go up 2 and over 3, I'm not going to be getting closer to my line. So then I need to go down 2 and back 3, and I hit it, and I'm done. And there's my second line. And I just need to name the point where they cross, which is right here. Let's name it. I go back 1, 2, 3 on the x-axis and up 1 on the y-axis. What I'd like you to do is go ahead and do number 3 and number 4 on your own and bring those to class tomorrow, and we'll discuss those at the beginning of class tomorrow. All right. 4 has a slight challenge to it, but it still comes out, I'll tell you, the answer does still come out to be all whole numbers, no fractions, okay? So see if you can figure out how to do that one on your own, bring that to class. And number 3, also graphs from a fraction. So see what you can do with those last two, and we'll discuss them as a class tomorrow.